Okay, so I found something kind of funny. Again, I am doing this as a recap. So once again, this is a recap of a project that I did 5 years ago. I don't know if you can. No, it's not here. Uh, and uh, and the whole idea is to entirely recap, maybe do it a little bit cleaner, some area prioritization for biodiversity conservation, which was a group of species in Mexico State, because this belongs to my master's, where I studied in Mexico. So yeah, and this is the second video. In the first video, I was going through what's going to be the whole purpose and what I will be basically doing, and a little bit of the explanation of the actual project. Now, I will go ahead and because I knew there was kind of a small presentation, and so I will go ahead and go through this one very quickly to give even a better overview of the whole thing, right? So this presentation was performed to the people that I used to work in, because right now I live in Portugal, and this was done to the people from the research institution that I used to belong to in a town called Évora in Portugal. So there are a lot of things, obviously, because this was like their introductory presentation. So a lot of things change. Most of it did not. So yeah, so I'll go very quickly, just as fast as possible. Again, I'm trying to stay within 10 minutes. Yeah, so I do remember starting to talk about, there are a couple things that I did wrong over here with Spanish. Talking about the strategies for conservation that we have, or that there are. It's not exclusively for Mexico, but for an entire planet, right? That you can do it through the protected areas, you can do it through marine prioritization, the ransom sites, which is the interlude between land and the sea, and other type of management, right? Now, there is the whole idea of building a theoretical prioritization is to be part of a strategy that it's well funded. This is, well, it has good fundamentals. This is because, for example, some of the protected areas are defined mostly because of their beauty, or because someone is related to the actual site. But there's 20 years ago, maybe 10 years ago, you still have a lack of actual fundamentals, like a good ecological based way to define those areas, right? So back in 1999, this approach starts showing up, right? Like the systematic conservation planning. So this is, yes, sure, this is the updated protocol back in 2010. I guess there's going to be something new or recalibrated, but the whole idea is to have a better fundamental, a better argument in terms of the ecological needs, but at the same time trying to involve the populations, which I do understand that can be wishful thinking. So those were the steps, and the strategies, the methodologies that we do in this project, this is the complementary part, right? Like, how do we help? How do we support this? In theory, I do know that the products that we did in this project were supposed to be used in a more practical sense afterwards. Hopefully that has been the case a little bit, or because we don't want to have this kind of information just concealed in the academics, right? That which happens, and it's like sad. So this is the objective: prioritize conservation areas for vertebrates in Mexico. In this case, it's birds, amphibians, mammals, and reptiles, right? For the exercise that I'm doing in these videos, it's going to be mainly, well, not mainly, it's going to be only amphibians. I decided that I mentioned the reasons in the past video. But some of that has to do because they are the most vulnerable, but also because I want to reduce the amount of data that I'm going to be processing, right? Because I'm more interested right now in this exercise, I'm more interested in replicate the methodology, maybe do it again, do it a little bit cleaner and that kind of stuff, right? But it's just to refresh because it's been a long time since I've done something like this. The methodology has those 4 steps, getting the species data, getting the climatic variables, the modeling, and the prioritization. Well, there's a 5th one where it's like we need to analyze that information. So for whoever don't know, so the Mexico state, it's located basically in the center. Actually, if you see, like, it conveys something, the city that most people know, which is Mexico City, right? And on the right side you have map with most at the time, because there have been doing a little bit more protected areas. Like in orange you can see the state base, and in blue you can see is federal but focused on birds, right? Now, species data, so we need to, where to collect the data? Well, a lot of this was, we decided to put a more conservation interest approach. So this is why the data for the species, well, the definition of the list was based on the national and international conservation status, right? And these are some of the places where we got some of the information. Papers, absolutely not. But scientific collections, specifically one, which unfortunately is Mexico has, or hopefully had, a very centralized science hub, let's put it that way, which is a university in Mexico City that they are well more experienced and so on, right? But aside of that, we have online databases like those 4. Right now, GBIF is like the well-known database, right? And most of the times, whatever you find in the other ones, you can find it in GBIF. Now, for the climatic variables, I also used biotic, which is land use. It's land use, but divided in 7 categories that were seven categories. But now we model the distribution, all the environmental suitability for the past, for current, and for future. For the 1970s, for 2010. And technically for 2040, which we need to keep in mind. Those future variables might have already an update because it's already old information, right? Let's just keep in mind, like, this is why it's important. Like, I got the idea to replicate this project because it would be nice to do the whole process where I just change the species or change the variable, right? I want to be sure that the script could be friendly for someone else to use. That would be the idea of the whole thing. Oh yeah, well, so for example, like, yeah, sure, for environmental things, there have been a lot of studies to do that, but how do you do that with land use, right? So there's this thing like line change modeler, which is, I don't really remember the whole theory behind that, but it's based on an algorithmic, like, Markov change, whatever things. So this is how we did it. So this is also like how we because usually the only information that we have is the maximum, minimum, and precipitation. But there's a standard that tells you using this kind of software you can do 19 climatic variables, which is even a little bit more expensive. Those 19 climatic variables are, I'm not going to mention all of them, but are, like, for example, the mean precipitation or the hottest month or so on and so on, right? Now for the modeling, here I think, okay, so here I was just considering Maxent. Let me see something very quickly. Okay. Yeah, so this is one of the things that changed completely, right? Because the modeling was not performed using this specific algorithm, but an assemble of 9 algorithms. But the principle is a little bit the same, yeah, because we need to have the occurrences, we need to have the variables. And then we need to calibrate to the area that we're going to be doing, which was not Mexico State, because we know that biodiversity does not limit itself to political boundaries. So what we did was take basically most, or I think it was all Mexico at the end. So you put that, you use the algorithm, and then you have your scenarios, your distributions for each one of the times. So this is a little bit of the biomode proposal. This is the package, the R package that we use, where we can find all those models, right? Now for the prioritization, we use this software, which uses the products for the biomode algorithms, and it plays a little bit different. Maybe I can go into that when I get to that part, right? Because it's another kind of worms. Like for example here, this was another proposal, right? To use 2 algorithms that this zonation uses. At the end, we end up using only core area zonation because it's based on species richness, right? So we wanted to know where do we have the most of the species. And because we are working with the whole past, current, we work with past, current, and future, we wanted to see how that prioritization considers that transition of time. Yeah, so prioritization, high intensity, blah, blah, blah. Yeah, so this is thinking, again, we only used one algorithm of those. Like, for example, here is there's some mistake, like distribution interaction component is something you enable for each one of these guys, right? At the time I thought it was something separated, but it's not. It's something you enable. And then obviously we need to see if the results are logical, they make sense. Unfortunately, I remember that I was not able to do the whole actually special landscape description, right? Like to understand where the species are, like in terms of the terrain, which was actually one of the big questions that came out during my dissertation. Also here, there was another type of analysis that we did at the end, which is the gap analysis, which was comparing the effectiveness of our prioritization and the prioritization against the protected areas. So yeah, so I think that's it. Hopefully I can make it the whole thing and you will see a little bit more. Yeah, I do believe that this could be like a very awesome thing, and it's a very easy, accessible thing to do that should be replicated in many other places. I guess there has to be more studies like this, but for decision makers or people who work around decision makers, this should be something that be useful in order to like take decisions and strategies what to do in their land, right? I'm gonna stop this here, and I think the next time I will try to show a little bit of the maps for the species, like for the occurrences, and maybe the spreadsheets of how the characteristics of how were they picked. So yeah, so thank you, and let's keep it going.